We are live. Let's get everything going. Get the experiments going for the day. Just trying to get the camera set up here. Get the lighting right. I think we're good to go. How you doing, Giga Bean? What do I got here? Let's turn this light off. All right. Get the stir bars going. Yep, last stream of 2024. Here we go. In goes our deionized water. And a little bit over here. Almost top it off. How's that look? Yeah, it looks pretty nice. Got to add our universal indicator. Where'd I put it? Let me get this wiped off just a little bit here. I got some residue on there from previous experiments. A little bit on this one as well. Yeah, we don't want that gunk on there. That looks a lot nicer. A little nicer, maybe. My goodness. The lighting is so good you can see all the street marks on my stuff. Okay. Let's start adding some universal indicator. Hello, Giga Bean. All right. Here you can see my universal indicator is a nice green color, indicating that it's neutral. And when I add it to the deionized water, it turns a yellow color, indicating it's slightly acidic. That's just from the carbon dioxide that dissolves into any water that's exposed to the atmosphere. That looks nice. Try a couple squirts over here. It's green. Add it to the deionized water, and it takes on a yellow color. Then we'll start messing around. Adding acid or base. See what happens. We'll add more color if we need. I think for now that looks okay. Straighten up just a bit. All right. All right. Where's my pH indicator? You got to forgive me. I just recently cleaned up the lab, and it's a little tough for me to remember where everything is right here. So yeah, here's our values of pH that we may see. Everything looking good and yellow now, which is just slightly acidic. So now we're going to fiddle around, baby. Let me get that right there. There we go. I'm going to add a drop of base over here on the left. Boy, that turned violet down there at the bottom. Look at that, man. We went from pH 6 to pH 10 pretty quick, didn't we? Yeah? Sure enough. Let's see what happens if we add a drop of acid over here on the right. This acid I'm adding is hydrochloric acid, the same acid that's found in your stomach. We'll add a drop. Ha-ha! And it goes directly from pH 6 to pH 3. Nice. Very nice. All right, now we're going to go over here on the left again. I'm going to add a couple drops of hydrochloric acid to the mixture that's quite basic. Let's add one drop to begin with, and it goes. See what we get. You can see a little bit of red growing in there. And wow, it looks like what's going to happen? It looks like we're going to relax to a pH of about 6, doesn't it? Yeah. Yep, add another drop of acid, and that should take us all the way down to pH 3. Hey, thanks there, Giga Bean. Giga Bean went and checked out my 2024 review of experiments, the latest YouTube short I put out. Over here on the right, here we go. Let's add let's add a drop of base and see what happens. Sodium hydroxide base. Got a nice little rainbow action going on there. Looks like we went up to like a pH of 4. Let me add another drop of base. And it goes. And we went from 4 to 10 pretty quickly. This is a chemical reaction that's happening. So when I add sodium hydroxide, that's the base. When I add hydrochloric acid, that's the acid. These two things neutralize each other. So if they're completely balanced, you'll just have salt water and the pH will be 7 and everything will appear green. Over here in this flask on the right, we have an excess of hydroxide, which means our pH is going to be 10. Over here on the left, we've got a pH of 3, which means there's an excess of the acid. And you can end up with intermediate pHs as well. There we go. Let's add a little drop of hydrochloric acid over here on the right. Nice. And we'll do a drop of sodium hydroxide over here on the left. Looks like this has been neutralized, yeah, over here. Looks like we've hit neutral. Maybe a little acidic, so that's like a slight yellow-green to my eye. Isn't that a gorgeous color that you see over there? Isn't that just beautiful? Look at that. Love seeing the different patterns that develop. And oh yeah, over here it looks like we've gone neutral as well. I'm going to go ahead and add a drop of acid to both. So here we go, a drop of acid here, a drop of acid here. Everything's gone nice and red. pH of 3. We're going to add a drop of base to both. Drop of base over here, drop of base over here. That's pretty. Very pretty. I'm going to place this down here and pull that up when we need it. Very cool. What kind of colors are we getting here, man? Sodium hydroxide. Sodium hydroxide. Oh, that's nice. Hydrochloric acid. Another drop of hydrochloric acid. We'll drop of sodium hydroxide. All sorts of there, little rainbow action. Little rainbow action. Nice. Looking cool. Looking cool. What am I in here? Looks like a little acid. Now a little bit of base. A little bit of base. Boy, I love that. I love those swirl patterns you see sometimes on the addition of base. Go a little acid over here, a little acid over here. Little base. Chicken Nugget wants me to add some sugar. I don't have any sugar. I apologize there, chicken. So sorry about that. I don't have sugar down here in the lab with me. And sugar is neither an acid nor a base, so it's not gonna affect the pH. Sugar would not affect the pH. Now, of course, if we oxidized it to carbon dioxide, that certainly would. It's pretty, just gorgeous. There we go. I think I got this all set up. Little base over here. Little base over here. Got a little rainbow action going over there on the right. Haha, Giga Bean, I wish. I wish I had some sodium potassium alloy. I do not. You know, I've never messed with it. I do too, Zach. Totally do. 100% loving me some science. Thank you there, Anon. I appreciate that very much. Yep, we're just adding acid or base to a mixture of chemicals known as universal indicator. And that allows us to see a variety of colors based on pH, because the universal indicator changes color depending upon pH, of course, which is just how acidic or basic something is. Hello there, Bella. What's going on? Welcome. Bella Mishmella. I love the name. That little base over here. Now we're going to add some acid to both. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. It's just this stuff is a lot more concentrated. Let's try this experiment. I'm going to do something new. I want to try it a little. I don't know if it's going to work or not. But a lot of people will sometimes ask if you can do this experiment with household stuff. Well, we're going to see if we can pull it off. Hello there, Magnet. Oh, Chicken Nuggets just saying Magnet. So here's what I'm going to do. I'm going to get a different flask up here. Let's see what I'm going to use. Let's try this one. All right. So I'm going to take this one off. That one makes a bunch of racket anyway. We'll pop this one on. All right. I'm going to just lower this just a bit so we can focus in on this particular experiment, okay? And what I'm going to do is I'm going to see if we can actually use cranberry juice as an acid-base indicator. Cranberry juice contains a class of compounds known as anthocyanins, and that's what gives this nice red color to the cranberry juice, but it should also allow us to get other colors to the cranberry juice as well. Janine, thanks for joining in. All right, so here we go. I'm going to add my little stir bar to my flask. There we go. Get this turning on. We're going to add the cranberry juice to the flask. There we go. Cranberry juice, and it goes. And you can see at the start it's got a red color. And that makes sense to me because anthocyanins tend to be acidic, red in acid. And if you read the ingredients here, let's see. Let's read the ingredients. It's a little tough to see here. Let me pull it back a little bit. So I got filtered water, cranberry juice, natural flavors, citric acid, fumaric acid. So this is starting out quite acidic. And anthocyanins indeed are red in acid. I'm going to add a little bit of water here just to give us a little different color. There we go. So we've got our cranberry juice. How you doing there, Idi Amin? What we're doing right now, bud, is we are trying to see if we can use cranberry juice as an acid-base indicator. All right, I just poured the cranberry juice in here. I've added a little bit of water. And now what I'm going to do, so Gigabing asks, wait, so water is burned hydrogen, then is hydrogen peroxide double burned hydrogen? Good question, not quite. Wait a minute, is it more oxidized? No, it's less oxidized. -1 versus negative. No, wait a minute. Water's oxygen's -2. Peroxide oxygen's -1. So yeah, in a sense it is. That's correct. Hey, thanks there, Bella Mishmella. Okay, so we've got our cranberry juice on here. I'm going to add a drop of sodium hydroxide base. It's going to make this more basic. Let's watch what happens. In goes the drop. Not much is happening. I'm going to need to neutralize the citric acid and fumaric acid that's already present. Thank you there, Anon. So let's add another drop of base. Ooh, we're going to have to add some more. Let's add 3 drops of base, 4 drops of base, 5 drops of base. Now, the pH isn't changing much because I'm going to have to neutralize the citric acid and the fumaric acid that's in here before the pH is going to rise a whole lot. So, well, I forgot how many drops I added, but there's roughly like maybe 4, 5, 6, 7, 8, 9, 10. Man, there's a lot of acid in there. Maybe nothing's going to happen. 11, 12, 13, 14, 15, 16. This might be a dud. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Holy cow. That is eating up some of my base for sure, and I have not changed the color a bit. I'm going to get a big old squirt and just squirt it on in there. What happens when I do experiments that I haven't practiced first, but that's all right. You're just down here in the lab goofing around. I'm going to give this a big old squirt. Here we go. Squirt that baby in there. There's your color shift. Come on now. There's your color shift. That's correct, Adiaman. Citric acid is indeed an organic acid. I don't know if you can tell. You know, we got a pretty major color shift here. I probably should use a control so we can tell, you know, what these cranberry juice look like at the start. So let me get the control out so you can see that. So here is some cranberry juice over here on this side. That's what it looks like at the start when it's very acidic in the cranberry juice. It's got this nice red color. And as I've added quite a bit of base, you can see it's, I don't know what to call that, like a brownish red. Let's keep adding some base and see what happens, okay? So I'm at a couple drops here. There's like 4 drops. I didn't see much change. So let me get a big old squirt here. Is that acid I added? Nope, that's base. Big old squirt. Not a whole much more change, huh? Let's add a little bit more. Trying to really get some base going on in here. Make it really basic. I don't think there's much color change. Do you folks? I think that's as far as we're going to drive it. I think that's as far as we're going to drive this cranberry juice. Another thing I can try, this is kind of fun. I could try adding, let's see, put user in timeout. We got someone doing some stupid stuff, so I'm going to go ahead and just put him in timeout. Yeah, I don't put up with like just so you know, I don't put up with trolls. I just ban you real quick for like 24 hours. All right. Happy New Year, Adiaman. Happy New Year. I think I'm going to try adding a little bit of milk and magnesia to this. Let's see what happens if I do that. Just a little bit. All right, so I got my milk and magnesia. I think some of the magnesium might complex a bit of the, it might complex some of the anthocyanins, and we might see an interesting color change. Here we go. All right, let's try it. See if you get some interesting color here. Interesting color shift. No, I don't know what's going on there. I should have practiced ahead of time. Let's just do this. Let's just add it straight to this bottle and see what happens. I'm going to go ahead and add a little bit of milk and magnesia to this. I'm just dinking around at this point. We are just messing around and seeing what happens. Thank you there, Anon. Yeah, check out some of the shorts I have. I got quite a few out there. Okay, so here I got my diet cranberry juice. We're going to add some milk and magnesia to this and give it a big swirl. Just see what happens. And it goes. How you doing there, Dr. Hayes? I just add a little bit of milk and magnesia to some cranberry juice. I'm going to give it a shake and see what happens. Here we go. Shift to like an orange color, yeah? I think so. Yeah, not much interesting going on. Hello there, Jordan. Hope everything's going okay. These experiments are a little bit of a dud. So let's get back. Let's get back to the normal. There we go. I'm doing well, Dr. Hayes. I hope you're doing well too. Doing well too. Here we go. Right now, I've got two different flasks on here. They both contain the same thing, universal indicator and water. And you can see both of them are red, which means that the pH is 3 in both of them. And we're going to check out what happens if I start adding a little bit of base to both. So here we go. I'm going to drop a base over here on the left. Let's do 2 drops. 2 drops of base over on the right. Let's see what happens. Get some interesting color changes, yeah? Look at that beautiful color shifts. Beautiful color shifts. Sina, chem student. Tell me what you're studying, Sina. Some of them do, Dr. Hayes. I don't know what that means, Dr. Renard. I don't know what shadow band means, so you have to explain that to me. How you doing there, Jesus? Somebody tell me what shadow band means. I don't know. How you doing there, Mike? Good to see you. Glad to see you, Jesus. Yeah, oh man, we got some beautiful color action going on today. Isn't that gorgeous? Absolutely gorgeous. Yep. Oh, that's right. That's right, George. I forgot. I forgot. Got some interesting colors going on. When your account doesn't get public attention, it should get. Gotcha. Is the video showing already recorded? Paraket, this is live right now. We are live and doing experiments. So we are in the act of doing some experiments. You guys got questions about anything, or you want to maybe drop your favorite element in the chat, or suggest an experiment for me to do? Mezzis, aerospace, and never understood chemistry. Have I done crystallization? I have, Dr. Hayes, but I tend not to do. I'm not a synthetic chemist, and I tend not to do crystallizations or recrystallizations. Although I have done some in my time. Is formaldehyde just water with a carbon atom in the center? Gigabean. I mean, you can think of it that way. It's like a CH2O. Sure. I mean, you can think of it that way. Of course, it's going to behave very differently than water. Thank you there, don't know name. Yep, what we're doing is we're adding either acid. I'm adding acid right now to both flasks, or base. I'm going to add base at this point. Here we go. I'm adding base now to both of these flasks. And we're seeing what happens to the resulting colors. The colors change because I've added universal indicator to each flask. And universal indicator changes color depending upon pH, which is just how acidic or basic something is. So over here on the right, you can see this is mostly neutral. Of course, in the middle of the vortex, it's a different color. But the flask is mostly neutral. From the green color, I can tell that. I agree, Dr. Hayes. So I'm going to add a drop of acid, hydrochloric acid, to the center of this one on the right. Actually, a couple drops. You can see the red color develop as the pH drops. Mezzi wanted to use electrolysis to clean the golf clubs. Interesting. Not heard of doing that, but hey. Now I'm adding base to the one on the right. And I'm going to add some acid to the left. Dr. Hayes, these solutions are solutions of universal indicator. And then I'm just adding either 20% by weight hydrochloric acid. Thank you there, Zach. I appreciate that. Or 20% by weight sodium hydroxide. And then I'm seeing what happens. So right now you can see the flask on the right is a pH of 6. The flask on the left is like a pH of 4. That's right, Dr. Hayes. You either add acid or base, and the colors are going to change. So let's add a little bit of base over here on the right. 2 drops. A little bit of base over here on the left. You can see when you add base, the pH goes up. It shifts to more blue or violet colors. This is the chemical reaction that goes on. Sodium hydroxide and hydrochloric acid react to form salt and water. If these are perfectly balanced, we'll be at pH 7, which is neutral. In both of these flasks, there's an excess of sodium hydroxide, and that's why the pH is kind of high. Over here on the left, it's kind of indigo. Over here on the right, it's kind of violet. So I'd say this is like a pH 9. Over here, there's a pH of 10. There's a little more hydroxide over here than there is here. So all I'll do is I'm going to add a drop of hydrochloric acid. So I'm going to add this to solutions that contain a lot of this. I'll add 1 drop each. So 1 drop over here on the, actually it's like 1.5 to the left, and 1 drop to the right. And of course, you can see that the pH has dropped from like 9 to maybe 6. Over here, there's a lot of colors. That's because the solution hasn't homogenized. I think it's kind of interesting because you can see in the center of the vortex, the pH is like 3, and on the outer edges, it's more neutral. How you doing there, Eddie? And it looks like this is relaxing to a pH of 7. Did I know that if oxygen is an unstable element, which means if I find it on another planet, it means there's life? I'm not sure I did know that. Is that true? Good to hear, Eddie. Let's add a drop of hydrochloric acid over here on the left, excuse me, on the right, and a drop over here on the left as well. So Dr. Hayes asks, if I completely neutralize the solution and make it green, is it safe to consume? And it's completely neutralized. I would say yes, as long as the dye that I added is not in the solutions. So Isabel and Dr. Hayes, I will not be drinking these solutions, even if they're neutral, because one of the dyes is a laxative. It used to be the main ingredient in X-Lax. So, that might end the live kind of quickly if I. Now, look, they're both green if I drank either of those, right? They're like green, it's pH neutral. Yeah, I'm not drinking that. I am not drinking that because one of the dyes in the combination is, thanks, Dr. Hayes. Thank you, Wanting Brand. Hello, Riley. Neil deGrasse Tyson said that. Interesting. That's interesting to know. I imagine he was saying oxygen as O2, so in elemental form, the way we find it here on Earth, O2. Oxygen can take on a lot of different forms, like it can be in the form of ozone, O3 molecules. No pear juice. So, George, what's happening is I have added universal indicator to both of these flasks. Universal indicator changes color depending upon pH or how acidic or basic something is. So if you look here, both flasks are roughly green in color. Maybe this one's a little bit blue. So both flasks are either neutral, like this one over here is green and neutral. The one over here is probably maybe just a little bit basic. So you can just match the color to the pH and figure out whether it's acidic or basic. Now, the way this pH scale works, here I'll add a little drop of acid over here to the left, excuse me, to the right. The way the pH scale works, the further you get from 7 on the low end, the more acidic you are. The further you get from 7 on the high end, the more basic you are. So over here you can see a variety of colors, and that's just because after I add the acid, it doesn't homogenize immediately. It takes a little bit of time. You can see the center of the vortex is remaining acidic at pH 3, whereas the rest of the solution has found its way to pH 6. Is O4 possible or O5? I do not think so. 1, 2, 3 drops of acid on the left, and boy, that sure did shift like a pH 3 very quickly. That's correct there, Fatih. Fatih Baran. Oxygen combines with a lot of elements like silicon dioxide, that's sand, and aluminum oxide, and those create a lot of the Earth's crust. So long there, George, Mike. So long. Here we go. Let's add a drop of base over here on the left. Just one. Get in there. Maybe, Eddie. I don't know. I usually do this on the weekends. Let's add another drop of base over here on the left. I'm going to make this nice and acidic over here on the right. There we go. Let's make it nice and acidic. I'm adding hydrochloric acid to this flask. Hydrochloric acid is also known as stomach acid. It's the same acid that's in your stomach. It's just the stuff that I add is like 100 to 1,000 times more concentrated. I agree, Dr. Hayes. It's beautiful. So Sarav asked, where is the salt formation? Sarav, the salt that forms dissolves in the water. So you're just making water that has salt dissolved in it. Now at this point, there's not a whole lot of, salt present. I mean, there's a lot of sodium ions in here and a lot of chloride ions, but there's an excess of the acid. That's why we're at pH 3. So now I'm going to go ahead and add drops of base. I want to ask that when your glass tube liquid has green colors, so does it have any taste like water or something else? So yeah, when it's green, it's going to taste a little bit salty. I'm adding base to both, by the way. So 2 drops of base to both. It'll taste a little bit salty, but it also tastes a little bit like alcohol because the indicator that I add is dissolved in some alcohol, and the indicators themselves would have some taste. I have never, thank you there, Musa and Sarav. I have never drank this solution though because I'm not completely aware of the toxicity of the dyes, and so it's just not good to drink them. Hey, thanks there, every day. Glad you enjoy the videos. Glad to hear that. Yeah, if you like, if you like science short videos, check out my channel. I got a ton of them. A lot of fun stuff on there. Why is the card no number 1 and 2? Jordan, great question. Why is there number no 2 and 1? I could have put that on there, but pH 2, pH 1, pH 0, pH -1, all of those are going to be red. So 3 and below is going to be red, and 10 and above is going to be violet. So that it just doesn't change anymore once you get to pH 3 and below. That's right, man. Don't drink the forbidden juice. You got it. Fatih, one of the dyes is indeed phenolphthalein in universal indicator. There's 3 other indicators as well, 3 other dyes as well, but one of them is phenolphthalein, and phenolphthalein used to be the main ingredient in X-Lax, which is why I won't be drinking this anytime soon. You're welcome, Jordan. All right, see if we get some rainbow action going on. So we'd probably see the same thing. The potassium and the sodium, they're just what we call spectator ions. They don't affect the colors or the reaction in any way. I apologize. I don't have any potassium hydroxide with me, or I could show you. I'm adding base to both now. So what indicator would I use for pH higher than 10? Go blue, RL. Come on, baby. What indicator would I use for pH higher than 10 and less than 3? I got to try to remember this off the top of my head. I think lower than 3. I've used it before. I can't remember off the top of my head. I apologize. I'd have to get out my Gen Chem text and check it out. What's the difference between organic and inorganic? Gigabean, organic chemistry is generally described as the chemistry of um, molecules that contain carbon. Inorganic chemistry is going to be the chemistry of everything else. So Mezzi asks, would it take more drops of an acid weaker than hydrochloric acid to change the color? Sorav, can I form salt and show it? Not without boiling away the water. When it's red, what does it mean? Actually, I think that's the name of the person. I apologize. I don't understand. It looks like that's Arabic. I apologize. I can't read that. Hey, thank you there, every day. Dr. Hayes says that organic is fun if you understand. Inorganic is memorization. That's pretty cool, Fatih. I agree with you. Have I tried this with shorter tubes? And if so, do you notice much difference in how the colors change? Willock, let's try it, baby. Willock's got a great question. We're going to give it a shot. We're going to use smaller tubes. Hold on a bit. We're going to use some smaller tubes. All right. Let's give it a shot, Willock. Here we go. I'm going to use a smaller tube right there, okay? This is for Willock. We got... Oh. All right, let's get it started here. Here we go. I'm going to use a smaller stir bar, so in that goes. Ooh, look at that thing bouncing around, baby. Come on now. Let me turn this down, get it at a good little speed here. Okay, we'll get that going. Come on, get that little guy going. There we go. Stefan's first. What's going on? All right, here we go. Let's add a little bit of the water to this flask for Willock. You want to know what it looks like with a smaller tube? A more narrow tube? I know you're probably wanting a tube that's taller. I apologize. I don't have one. This is This is the best I can do for you at this moment. But yeah, I think trying this with different shaped tubes is going to be interesting. Okay, now I'm going to add my universal indicator. Thank you there, Dr. Hayes. Go blue! Go blue, baby. All right, here we go. In goes the universal indicator. Give it a nice little squirt here. It turns yellow as expected because remember, we all know that any water that has been exposed to the atmosphere will be slightly acidic when carbon dioxide dissolves into it. Okay, now, let's add a drop of acid over here on the right. Two of them, huh? Mezzi, that's correct if you're using just phenolphthalein. It goes colorless or pink. Now over here on the left, I'm going to add a drop of hydrochloric acid, just a single one. All right. And now I'm going to add a drop of base over here on the left. And it goes, and a drop of base over here on the right. What's the universal indicator? SARAV. Here's what it is. Here's what universal indicator is made of. It does feel like an RGB animation. So universal indicator is made of all of these indicators. So first there's thymol blue, which displays these colors at different pH values. So thymol blue is sort of the heart of the indicator. You can see that this particular indicator almost gets all the colors of the rainbow, but it needs some help. And so to let this get to all the colors of the rainbow, what you do is you add other dyes. One of them's methyl red that shows these color shifts. Bromothymol blue. So if you'll notice, the methyl red helps you get the red and orange at the lower pH. The bromothymol blue helps you get the blue and the green at the intermediate and high pH. And the phenolphthalein, that dark pink color, which almost looks red, that allows you to get to violet at very high pH. So, if you just go across red and yellow and colorless, that gives you red. If we go here in the middle, right? If we go here in the middle, yellow and dark green and colorless, that gives you like a light green. Up here at the high end, a deep blue, a yellow, a deep blue, and a red, that gives you a violet. That's kind of how that works, okay? Doing all right, Sarah. How about you? Let's add a drop of acid to both of these. Let's get a little drop of acid over here on the left, a couple drops of acid over here on the right. See what we got going on. Let's add a little more acid over here on the right. Thank you there, Dr. Hayes. All right, we got them both. Hello there, Kat. Let's add a drop of base over here on the left. It has been a while. And a drop of base over here on the right. Let's go 2 drops over here on the right. There's more material over there on the right. Hello, Henry. What's going on, Henry? Let's see if we get the rainbow going over there on the right. Hey, Henry, I block people pretty quick when they spam the comments. Just letting you know. I usually don't even. Yeah, we're done. We are done. So long, Dr. Hayes. Yep, I can. I think you could Giga Bean if it's diluted enough. Yep, we're done. So we are going to put Henry in timeout for 24 hours. So long, Henry. Yeah, it's all right. I block people pretty quick when they spam the comments. I don't put up with it. It's just not fun, man. It's just not fun. Here we go. A little bit of blue. Excuse me, base over here on the right. A little bit of base over here on the left. Yeah, well, I think it'd be cool to get a really thanks there, Jordan. I agree. Like a really long, tall tube. I do not have one anywhere nearby. I'm looking around. Yeah, I've got the longest, tallest tube I've got there. So That's going to be what I've got to go with. I'm curious to see it too, Willock. I think it's a great, great idea. Problem is they cost so much, right? These flasks are not cheap, man. They are not cheap. We'll drop the base over here. Whoop. I want to get this. I think there's some color that we're missing. There we go. There's some color we're missing over here. I had the angle wrong. Let's add a little bit. Let's see. It's going to go quick, of course. I'm going to add a drop there. It's so pretty. Yeah, it's beautiful. We'll drop a base, send it back to a high pH. Very beautiful. We'll drop of acid, hydrochloric acid, send that pH back up. Excuse me, back down. Add another drop of acid. All right, let's add one more drop of acid. I want to try this just for the heck of it. And we're going to turn this off. And then I'm going to start adding just a bunch of base up here at the top. Let's go like 3 drops. 1, 2, 3. Let's see what happens. Let's just see what happens. You can see the swirls developing. Of course, the acid and the base, they neutralize each other, and that's why you're kind of seeing a green color develop. But look at those swirls. I mean, they're just really pretty. It's just interesting to see the solution as it reacts and homogenizes. I think you can kind of see the base sinking, can't you? Like that there's some basic material that just seems to be slowly sinking. Look at those swirls. It's gorgeous. Up here, I can see a trail of acid. Man, that's gorgeous. Now I'm going to chase it with a little bit of acid because it looks like the base is kind of sunk to the bottom. Although I don't know. I think there's still some action going on here. Beautiful. Huh? A couple drops of acid. Add a drop here. 1, 2, couple drops of acid. Look at it. It's kind of just sink down there like a cloud. It's like the day, the dawn breaking through the night. Oh, I love it, Fatih. Hydronium versus hydroxide, biggest rivalry ever. I love it. How does an acid form? Gigabean, an acid is going to be a substance that has a chemical entity that we call a proton, an H plus ion, a hydrogen atom with a positive charge. And acids are things that have those protons in their molecular structure, but they give them away pretty easily. That's sort of the definition. One way you can define acids is they give away protons easily. This is really pretty. Indeed, Fatih, there are a lot of definitions of acid. So my question is, where in the real world would a chemist apply the principles of this experiment? Well, a lot of people apply the principles of this experiment when they check the pH in their pools, right? You got all these color systems that allows you to figure out what the pH of the pool is, and then you add either acid or base to adjust the pH accordingly. I'm thinking it, man. I agree. It's really pretty. I'm gonna add a drop of base just to see what happens. It kind of looks like it's settled for a little bit. Here we go. Let's add some drops of base. 1, 2, 3. You can see it's very dense. It sinks rather quickly. That violet grows back in. Mezzi likes applied science. I like theoretical science. I mean, I like them both, but I really do like understanding how things work. So I really enjoy theory. Why don't you drop in the chat? Just write theory or um, theory or application. Which do you like better, theory or application? How does a positively charged hydrogen atom work? So, gigabean, a hydrogen atom is probably the most simple atom that there is. In fact, it is the simplest atom that there is. A hydrogen atom consists of a proton, which has a positive charge, that is surrounded by an electron that has a negative charge. So it's just got two particles, a proton and an electron. And you can think of the proton as, this isn't a perfect analogy, but we use it a lot. You can think of the proton as kind of like the sun or the earth, and the electron like the moon circling the earth. Again, this isn't a great analogy, but it works. So you've got this proton electron system that's neutral because the proton's positive and the electron's negative. But if the hydrogen atom loses that electron can go other places to other atoms and do some chemistry. Then all you have left is a proton, the positive one charge. And so that's how it works. That's right, Fatih. The chemist has entered the chat. Fatih is definitely a chemist, dropping the chemistry bombs. Look up here. Y'all notice that? You see that sort of, there's like two layers of of low pH 3 up here at the top, which is kind of interesting. Sarah wants me to add some zinc to it. So y'all want to see the reaction between zinc and hydrochloric acid is what it sounded like. We can do that. You're just gonna have to give me a second here to generate some zinc. Do I have some pennies with me? If I don't have any pennies down here, I'm not gonna be able to do it. But if I have some pennies down here, I can melt the zinc out of the pennies, and then we can react it with some hydrochloric acid. Give me a second here. I'll see if I got some. Where are my pennies? I do not see any. I do not see any pennies. We might not be able to do this. Yeah, I don't know. Oh, I do have pennies. Here we go, baby. And then I'm going to need, yep, I got this. I got this. I probably shouldn't do the melting of the penny. Wait a minute. Do I have I need a pair of tongs, and I don't know where my tongs are. I'm not holding this penny in my hand. Yeah, I don't know where my tongs are. Give me a second. Ah, I think I know they're here. Okay. All right, here we go. Somebody wants to see some hydrochloric acid reacting with some zinc. So I'm going to describe to you what I'm going to do, but I'm not going to do it actually on the live because I don't think I don't think YouTube would like that. So what I'm going to do is I'm going to take this penny here. All right, then take this penny, and I'm going to melt it, and I'm going to get the zinc out of it. And zinc reacts with hydrochloric acid. So zinc will react with this stuff, and we're going to show you that, okay? So let me just go ahead and get the, I'm not going to show you on video me doing this, but you'll be able to hear me doing it. All right, I got a little beaker of water ready. I'm holding the penny in a pair of tongs, and I'm holding the penny above this beaker of water. Get this blowtorch going. All right, we got the blowtorch going, and I'm going to heat the penny, and we're going to try to get it to melt. Come on, baby. It's starting. I'll show you the result of it. Almost done. Almost done. I can see the bead forming of the melted zinc. It's good and hot. All right, you heard me drop it in the water. And now I can show you the results of my experiment here. Ow! It was hot at the top of the glass. Good thing I had some gloves on. So here's the beaker. There we go. Here's the beaker with the penny that I just melted. All right. I'll get the penny out so you can see it. And then we'll react it. So here's the melted penny, at least the outside of it. So pennies nowadays are made of zinc. Yeah. And you can see that the outside of the penny is copper coating, and the inside it dripped out. So you can see the drip of the zinc. The zinc is still in there. So let me get the zinc out. Here's the piece of zinc that dripped out. All right, there it is. See it? There's the piece of zinc. So that's zinc metal. That, they make pennies out of zinc now. United States pennies, and they just, they coat them with copper so they look like pennies of old. So now what we're going to do is we're going to watch this thing react with some hydrochloric acid. So let's check that out. So let's see, what am I going to stick it in? I'm going to put it in something. Let's pop it in. This probably work right here. I'm going to use this. All right. Here we go. I'm going to zoom in. There's the zinc. Oh, sorry. Let's zoom in on this so you all can see it a little better. So that's a little piece of zinc. All right. And I'm going to start adding some hydrochloric acid to it. I'm going to add drops of it up here at the top. And you can see those bubbles forming. Those bubbles are hydrogen gas. Those are bubbles of hydrogen gas that is forming as the zinc reacts with the hydrochloric acid that I just added to it. So yeah, you're seeing one element, zinc, reacting with some hydrochloric acid to form another element, which is hydrogen. So those bubbles are hydrogen gas, as Fatih has written in the chat. That's H2 gas that we're watching being released. It's cool, isn't it? Yep. Very beautiful. Hydrogen gas. I'll try to write down the chemical equation for what you're observing right there. Let me write her down here. See if I got something I can write on. I do. Give me a second. I'll write the chemical equation. Oh, do I gotta get something to write with. Yep, that's hydrochloric acid reacting with zinc metal to form hydrogen gas. I will write down the chemical equation and let you see it here. So, let's see. We're going to have zinc metal plus 2HCl, which is dissolved in water, and that's going to form zinc chloride and H2 gas. There we go. Is it still going? Sure is. It sure is. We are making a bunch of hydrogen. Thank you there, Sarov. So here we go. Here's what's going on real quick. Let me back up the train here a bit. So the solid zinc metal, that's a little piece of zinc metal. We represent it like this. I added a solution of hydrochloric acid. So there's, some water, and in that water is some hydrochloric acid. We represent that like this. There's 2 HCl. This is stomach acid. It's just this stuff is a lot more concentrated than what's in your stomach. That's reacting and it's forming a salt that stays dissolved called zinc chloride. And it's also forming these bubbles here, H2 gas. That's how we're representing the bubbles that are being produced, H2 bubbles. So yeah, we're making the element hydrogen right there before your eyes, folks. And we're filling this flask with a bunch of hydrogen gas. Of course, most of it is just escaping. It's still kind of interesting. And that's going to be pretty acidic in there, folks. That's really acidic. Is a base an electron instead of a proton? Gigabean, a base is a particular substance called the hydroxide ion. It's OH negative. OH negative. And if you take an H plus and you add it to an OH negative, you get water. All right, I think you probably had enough of watching those bubbles there, yeah? We can go back to our other experiments. You got it, Fatih. We'll move this up. Yeah, thanks for hanging out on the live stream today. We did a bunch of different experiments today for sure. This is pretty hot. I'm gonna have to make sure to clean that up. Check this out. Check out what's happened to this. Isn't that cool? I've been jabbering on. If H2 is constantly being released, what would happen if I dropped a match inside? Mezzy, we can find out. I think most of the hydrogen gas probably has been escaping into the atmosphere. We can give it a shot. We can see. We can try. All right. So I'm just going to go ahead and move this over just a little bit. We're going to place this over here. You can see it's still bubbling. Yeah, sure is. I doubt we've generated enough hydrogen gas to fill this flask to do anything, but we can test it. I got a lighter here we can try. All right, here we go. Actually, it probably would work better if I use this. So I'm going to use this lighter that's got a bendy nozzle. Here we go. You know, that may have had a little pop to it. I don't know. It's sounding like it's doing it, but I don't know. We have to do the control, right? We'd have to do a control. Let me do the control real quick. See if it looks the same. If I do it in this flask that has not had anything added to it, because I did hear a little pop. I don't know if you did, but I sure did. Let's try again. I'm hearing a whoomp. Are you? I hear a little whoomp when I do that. Let's try it here. We'll do the control here. If I hear the same thing with this, then it's not due to the hydrogen gas. Yeah, it's I don't know, it's a little louder than the other one. You know, I actually think we were able to ignite some hydrogen gas in here. That's kind of cool. Anyway, thanks for the suggestions. Yeah, I think I heard a little boom. I don't know if you all did. You know, you can let me know your thoughts in the comments as to whether, as a result of the experiment I did over there, if it's if you think it was actually hydrogen gas in there. Oh, sorry there, Jordan. I haven't seen I haven't seen it. I'll pop it in there. Thank you there, Willick. Thanks for hanging out. So Jordan's been asking to put some salt and water. So I have some. Fortunately, I don't always have the materials that people want. I hope you see you around there, Willick. Let's go ahead and yeah, I think Gigabean. I think maybe we really did generate some hydrogen gas. I'm gonna add some salt to this flask over here. See if it changes the pH. All right. I got a little spoon or something. Little cup. Here we go. And you guys are keeping me hopping today. All right, so here is the salt I'm going to add. Just plain old sodium chloride. Well, Jordan wants to see there, Fatih, so we're going to go for it. Sometimes people just want to see things. So here we go. There's some salt. I poured it into this container. According to theory, hey, Classic Edits, come on, man. Classic Edits just sent me some money. I appreciate that. I really appreciate that. Come on, man. Much appreciated. Okay, we're going to go ahead and add some of this salt to this flask over here. Let's see if it affects the pH. If it affects the pH, we see a color change. In it goes. Kind of looks like a snow globe. As it's swirling around, it will dissolve. And appreciate that, Classic. Seriously. Really, really nice. Really nice. 20 rupees. Thank you. I didn't see a color change when the salt dissolved, and that just shows us that, sure enough, at least sodium chloride is not going to affect pH. But if I add a drop of base, boom, it goes immediately. That cool? Look at over here, man. We got the pH gradient going on. Let's go ahead and swirl. Let's go ahead and mix this up and see what happens, all right? Let's mix her up. Here we go. So what will happen here is if there's more base than acid, then the mixture will be either aqua, blue, or violet. Hey, don't sweat it, Giga Bean. Seriously, don't worry about it. If there's more acid than base, the mixture will be red, orange, or kind of like a yellowish. And if they're balanced, it'll be green. Let's find out. Turn it on and see what happens. It looks like we had an excess of base. Yep, we definitely have an excess of base. I'll add a drop of acid, try to neutralize it. Oh man, yeah, there's a bunch of extra base. Let's add another drop of acid. Oh man! And we're gonna add another drop of acid. Let's see if that neutralizes it. That got us to like a pH of like 6. Pretty cool, huh? Pretty cool. Back to doing our experiments. What are we doing? Drops of acid? Yeah, over here. We'll drop over here. If you add some sodium hydroxide to that zinc chloride, let's try it, Fatih. Great idea. So Fatih is saying we should try adding some sodium hydroxide to this solution, which you might remember we made some dissolved zinc chloride. And we might be able to get a white precipitate. So we're going to try that. Great suggestion. Let's give it a shot. All right. I'm going to add a little bit of water just so I can see what's going on a little bit better. Okay. So before I do that, we're just going to add just a bit of water so I can. All right. Just so we can see everything a bit better. And you'll notice that it's still fizzing. That's because there's still some acid left. So first we're going to have to neutralize. I mean, look at that fizz. It is still going a mile a minute. So there's still a lot of acid that's left in here. We're going to have to neutralize that acid first. So I'm going to start adding drops of sodium hydroxide base. You can see me up here at the top. I'm adding it. Let's see. There you go. So you can see me dropping it in. Well, shoot. Look at, I mean, you can totally see the precipitate. Look at it. You see it? You can totally see it. That white stuff. Thanks, Fatih. Great suggestion. You see that white stuff? So that tells us that, when the zinc reacts with the acid, it dissolves and forms zinc ions. And those zinc ions can be made to form a compound called zinc hydroxide if we add, uh, you know, sodium hydroxide to the solution. And that's that white stuff. So that white stuff is indeed zinc hydroxide. Great suggestion. Can I tell you the magnetic moment of the copper 2 ion? I cannot. I do not know what the magnetic moment of the copper 2 ion is off the top of my head. That's a really, you know what? You know what, Fatih? I think I'm going to do a video on this. I think a short video on this would be very interesting to, take a penny and dissolve, melt the penny and then, add some acid to it to get the zinc ions to react. And then we'll go ahead and add some sodium hydroxide back to make the zinc hydroxide. I think that might make an interesting short video. Yeah. Thank you for the, seriously, thanks for the suggestion, folks. It's always nice to have ideas for new videos. Fatih, you make the suggestions, man. I can always use inspiration. It's tough to come up with something. I try to do a new video a week, and sometimes it gets a little tough to dream up ideas. King, what'd you make? Let's add a drop of base over here. Another drop of base. Another drop of acid. Oh yeah, well, I'm starting to run out of steam here, buddy. I'm starting to run out of steam. I've been at this for a little over an hour. Yep, my back's starting to hurt. I got to clean up too. It's a mess down here. I mean, it is a mess. We did a lot of experiments today. A lot of different ones I haven't done before, which is always fun. Fun and nice. Yeah. The longer it goes, the more interesting it becomes with lots of questions. Yes. Um, Classic, I agree. We're having a good time for sure. Having a good time for sure. Not yet, but I'm gonna wrap it up soon. I am definitely gonna wrap it up soon. This is it's getting a little long. I can't I can't keep going like the young folks. After a while, the stream just kind of blurs my mind. I just can't keep doing it. So yeah, at some point we're gonna have to call it quits. Very cool. A lot of great suggestions, everybody. Thank you. I don't have any nickel solution. I don't mess with nickel compounds. I think they're just toxic enough that I don't want to mess. That's kind of my limit. If things get around the level of nickel, I don't mess with it. That's some pretty reactions we saw today for sure. Yeah, I tell you what, for the last little bit of the stream, why don't you drop in the chat something special you had happen in 2024 or something you're looking forward to in 2025? This will be probably my last stream of 2024. So, yeah, just let me know in the chat. Anything special you had? So long, Jordan. Thanks for the suggestion about the salt. Yeah, let me know any thoughts you have about 2024 or the upcoming 2025. What's going on, Combi? Make fission. That's not happening. I don't mess with radioactivity. The Minecraft movie release. Come on, baby. Well, welcome, Combi. I hope not, Fatih. I hope not. Yeah, I can never tell if people are joking or not. So I just take things literally unless it's pretty obvious. No, I'm not making any of that MILA. I don't mess with that stuff. I do not personally play Minecraft, but my kids love it. Isn't that cool, Combi? I agree. I mean, yeah, there's certain like little things that you can mess around with, sure. But it's not like I'm gonna I might get out a Geiger counter, for example. So, tangent, what's the experiment? The experiment is I've added universal indicator to this flask. Universal indicator is also known as rainbow indicator. It displays all of these colors at different pH values. pH just tells you how acidic or basic something is. So, right now, our pH is about like 9 or 10. You too, Fatih. Uh, Happy New Year to everybody. And so you can see if I add a little bit of acid to the solution, which I'm going to do right now, like 4 or 5 drops, pH drops. Do you? You got a little bit of that stuff? I do too. In my smoke detectors. I got the same. Yep. Nice. Be careful with that. All right. Well, folks, just like we've been, I do not classic. I don't mess with that stuff. I do not mess with it. I know my limits. All right, folks, I'm going to have to head out. I've been doing this long enough. Thanks for checking out some of the beauty of science with me. It's always around you. Always. I mean, every stinking breath, there's science there, and it's all magic. It's all just stinking beautiful. Take some time, listen to the rain, watch your sunrise, watch your sunset, head out to the lake, pet your dogs, and you all have a great and happy new year. And we're going to see you in 2025. Thanks for hanging out today, everybody. We'll see you next time.